Hi there, and welcome to webinar of Rakurs company. My name is Roman Permikov. I am a technical support engineer of Rakurs company, and before we'll start our webinar, let's check sound. Is sound good? Please, in case of any questions, type them in questions box. It's located in the bottom right toolbar of GoToWebinar. Is sound good? Okay. Let's start. In December of the last year, we released new PHOTOMOD version, PHOTOMOD 6.3. And in my presentation, I would like to tell you about new functionality of PHOTOMOD 6.3 version. And my presentation will be split into 4 main groups of PHOTOMOD improvements. The first group of new features is dedicated to digital surface modeling. The second group is associated with processing of UAS data. The third group will be devoted to processing satellite Pashbrom scanner imagery. And the last but not the least group will be devoted to all the other main features of PHOTOMOD. After we'll complete all the blocks, I will show you PHOTOMOD interface directly. So let's start. The essential features of PHOTOMOD 6.3 is ability to building True Ortho. Just to remind you, True Ortho is an orthophoto in which not only bare relief but also high buildings and other artificial objects are shown in orthogonal projection. So all the pixels in True Ortho looks like all of them were captured in nadir without any tilts. An option of building True Ortho is located in menu of building DenseDSM by SGM method. It means this option will be available just for users who have a license for DenseDSM module of PHOTOMOD. If you look at the parameters of building True Ortho, we can see that there are some options of filling new cells and applying of color balancing. So if to speak simple, an algorithm of building True Ortho is based on colorization of digital elevation models by colors of imagery. And that's why it's very important to fill null cells of them before we will create True Ortho. On the screen you can see forward, backward and rightward imagery that were captured by Oblique, Leica RCD camera, and True Ortho output imagery in the bottom right screen. Some samples of PHOTOMOD outputs: point cloud, 3D model and True Ortho. All of them were captured by were created based on the data captured by UltraCam Osprey camera on the center of Austrian city Graz. When we released PHOTOMOD 6.3, we supposed that 3D model, mesh or 3D tin would be created in open source third-party software such like Cloud Compare or something like that. But now, in current beta version of PHOTOMOD, we implemented new feature building 3D tin directly in PHOTOMOD interface. This feature is not included in PHOTOMOD 6.3, but it obligatory will be included in next PHOTOMOD 6.4 version. We will talk about this feature, we will look at it later. This sample is point cloud 3D model and True Ortho that were created based on data of Leica RCD camera on the center of Zurich. Thus, PHOTOMOD provides a full range of outputs from digital surface, digital terrain models, True Ortho, untextured and textured point cloud, and finally building 3D model. All the processing can be implemented in fully automatic mode. Apart from building True Ortho, in PHOTOMOD 6.3 we implemented some more important features. We changed default parameters of building DSM, and it means that we improved quality of DSM. Also, we implemented a full utilization of CPU in distributed processing mode. We provide a new filter of DSM, slope-based filter, and we added new capabilities of filtering point clouds in LAS format. Let's look at PHOTOMOD interface. This is project of aerial survey. It's the center of German city Dortmund. Let's load preliminary prepared grid in some small area inside of this city. Go to menu terrain, DEM, build DEM, DenseDSM SGM method. Initial approximation was prepared preliminary as a range of minimal and maximal height of this area. I checked it in stereo mode. Parameters of median filter were changed, so now we recommend you to use these parameters of median filter to provide a good results of them and output True Ortho. If you look at parameters of building True Ortho, as I said before, this set of options includes options of filling null cells of them and global brightness adjustment. I recommend you to leave all these options turned on, as is in this screen. And finally, I would like to present you new features of Create 3D Tin. As I said before, it's not included in PHOTOMOD 6.3. We have been actively testing these features right now. It looks like that. You can select one of the two strategy of simplification, digital elevation models, because 3D Tin is created based on them. If necessary, you can split 3D Tin by parts and change the resolution of texture for the 3D Tin. Okay. Okay, without clearing working folder, and until the building of DSM and True Ortho is working, I would like to show you a short video. It's 3D Tin that was created by PHOTOMOD. It is the center of St. Petersburg. Aerial survey was captured by a DMC camera. GSD is 15 centimeters. This area was processed based on about 40 images that were split into 3 strips. As you see, for imagery with 15 centimeters GSD, the output result, the output 3D tin, looks very good. If you visited St. Petersburg, you can see all the objects in this model. Well, building is complete. Let's look at output result. It is final True Ortho. We can compare it with source imagery. So, as you see, in output True Ortho, there are no any tilts, so it looks very good. Simultaneously with True Ortho, final DSM is uploaded to layer managers. But not only final DSM has been created in output folder. As you can see, temporal final DEM is kept at the same folder. Temporal DEM looks like that, and as you see, this temporal DEM is a result of building DSM without applying any median filtering and without filling gaps. With median filtering, without median filtering. What's about 3D tin? 3D tin is kept in TX3 format that can be opened in 3D mode. Well, output 3D tin looks like that. If we select this 3D tin, we can see that some of the textures are colorized by the same color. It means that this texture were captured by from the same imagery, of the project. Well, then I would like to present you some results of slope-based filtering. It is a UAS project on Le Bourget Airport in France. We preliminarily prepared DSM on this territory. In menu terrain DEM, slope-based filter is available now. Let me comment some of parameters of this slope-based filter. So, the first parameter is distance of points mutual influence. It's a half size of objects to be filtered. Slope angle is an angle between top of the object you want to filter and the relief and the bare relief. Deviation from smooth surface is the relative height of the heel on the top of which the object should be filtered from. How to measure these parameters? Let's open measurement window and let's measure a width of the object that should be filtered. I see that the width of this object is about 60 meters. Correspondingly, a half size of 60 meters is 30 meters. To measure slope angle, I put marker into the top of building and move it to the bare relief. As you see, approximately slope angle is about 30 degrees. Go again to menu terrain, then slope-based filter, 30 meters, a half size of object to be filtered, 30 degrees slope angle, a half meter deviation from smooth surface. Okay. Intermediate pyramid level allows you to accelerate filtering. The bigger the pyramid level is, the faster processing will be completed. I expect that low-based filter for this territory, for this DSM, will be completed in about 1 minute. Okay. Filtered DSM looks like that. The next step should be filling null cells, but to save time, I will load preliminary prepared them for this territory. Next feature I would like to talk you about is filtering of point cloud. For Le Bourget Airport, we preliminary prepared point cloud in LAS format. This point cloud looks like that. As you see, there are a lot of spikes, a lot of peaks below the main area of terrain. We need to filter all of these spikes. In menu terrain, LAS, right now filter LAS command is available. We need to set up source folder, set up output folder, select digital elevation model, which will be used as a border, and all the points, all the spikes that's located below 1 meter of this dam will be excluded. I'm not using DSM, I'm using them because I wanna save information about walls that's contained in LAS. Okay, Let's look at result. As you see, practically all these spikes, all the peaks that were located under the main terrain have been filtered. What next? The second group of features that were implemented in PHOTOMOD are features associated with processing UAS imagery. Firstly, we improved aerial triangulation of UAS imagery with a low block layout quality, with non-accurate external orientation data. Corresponding option appeared in automatic type point measurement window, and it should be noted that to use this option you need to provide a presence of projection centers, and you need to provide a right splitting block into strips. Also, we improved an interface of PHOTOMOD UAS. We changed the sequence of step of UAS wizard. Right now, relative orientation should be done before measuring ground control points. We did it to minimize an area of searching for ground control point. In previous version of PHOTOMOD, this searching area could achieve about 1000 pixels. Right now it's decreased significantly. Also, we added main toolbars. We get it from the general PHOTOMOD, and right now users have fast access to most used commands. And finally, after performing aerial triangulation, after performing UAS aerial triangulation, users can see new type of block processing report. This new processing report includes information about project properties, about processing parameters, and about ground control and checkpoint accuracy. Pay attention that this new processing report will be available just after finishing UAS aerial triangulation. Let's look at PHOTOMOD interface, PHOTOMOD UAS interface. As I said before, main toolbar from general PHOTOMOD is available in the PHOTOMOD UAS interface. In after measure type points window, you can see low block layout quality option. In default it's turned on. And just to show you how this project looked without type points, just by external orientation data. So it was an initial approximation with non-accurate external orientation data, and output result after applying of new option. New processing report is located in menu orientation, processing report. As I said before, it contains information about project properties, about coordinate system, GSD, and so on, about processing parameters, results of camera calibration, ground control residuals, checkpoint residuals, and so on. Next block of features is devoted to processing satellite Pashbrom scanner imagery. When we talk about pan-sharpening, for the most satellites, for the most imagery, the distribution of brightness value of panchromatic imagery correlates with distribution of brightness value of multispectral imagery. So for these cases it was enough to use typical photomode pan-sharpening method like PCA, HSV or Broadway. But in some cases panchromatic imagery distribution of brightness does not correlate with distribution of brightness of multispectral imagery. This situation we face with this situation when processed Pleiades and CAMSAT imagery. So in that cases classical method of pan-sharpening leads to false results in terms of radiometry correction. That's why we implemented new algorithm of pan-sharpening. Its name is EPCA, Enhanced Principal Components Analysis, and results of applying this method looks like that. It should be noted that you can use EPCA not only for Pleiades and CAMSAT imagery, but for all the other imagery as well. Next available feature is ability to export adjusted RPC. This option will be available just for blocks that were adjusted by RPC method with bias refinement. Let's look at the project. So preliminary, I would like to show you radiometry of CAMSAT multispectral imagery. It looks like that. It's result of pan-sharpening by using our old PCA method. You see that in terms of radiometry this pan-sharpened imagery looks wrong. But if to apply new EPCA pan-sharpening method, output result will look much more better. If we talk about export of adjusted RPC, this block of GUI imagery was adjusted by RPC with bias refinement, not by affine, not by scale and bias, but only by bias refinement. In menu orientation, export images to orientation to RPC is available right now. If we open output adjusted RPC, and compare them with source RPC, we will see that just first two lines have been changed, line off and SAMP off. All the other RPC leave as is. And final block of my presentation is devoted to all the other main features that were implemented in PHOTOMOD, and one of them is support of automatic import of UltraCam Osprey camera, automatic import of external and internal parameters of this Oblique camera. So metadata of UltraCam Osprey camera metadata file has a typical structure with information about camera parameters, with information about projection centers and rotation angles of all imagery. So we provide a fully automatic import of this file into PHOTOMOD, and we automate a procedure of direct georeferencing of such type of data. Also, we accelerate an orthorectification of images with combined type of terrain. As you know, while orthorectifying imagery, geometry correction cell size seems to be a very important parameter. Geometry correction cell size is calculated as a ratio of DEM cell size to GSD of imagery. And in previous version of PHOTOMOD, this geometry correction cell size parameter was the same for the whole territory. Right now, we implemented new option, adaptive geometry correction cell size. This option allows you to take into account a type of terrain. It means that for flat regions, geometry correction cell size will be bigger than for mountain regions, and for mountain regions, geometry correction cell size will be bigger than for urban areas. And finally, I would like to tell you about some features regarding stereovectorization. We implement some more tools of 3D and 2D snapping to midpoints, to coordinates, perpendicular snapping. We support ability of creating new user coordinate systems for aims of vectorization, orthomorphic coordinate systems, and so on. According to reports of our users from Great Britain, the productivity of using new stereovectorization tools have been accelerated up to 4 times in comparison with the previous PHOTOMOD versions. Let's look how automatic import of UltraCam metadata looks like. I will create new project with central projection type, coordinate system 33 zone of UTM, relief elevation between 350 and 500 meters. Oh, sorry, I'm using PHOTOMOD UAS interface. Let's do it in typical PHOTOMOD interface. Let's create new strip, add imagery from resources, We preliminarily prepared them. Go to menu orientation, import UltraCam orientation. The initial file of UltraCam camera looks like that. It contains information about camera parameters, principal points, focal lengths, rotation angles, and so on. Open. All the parameters is automatically corresponds to imagery names in project. I am using correct center values option to correct projection centers of imagery, because principal points coordinates of camera should be taken into account when we calculated projection centers of external orientation data. Next, split it into strips by image names, and direct georeferencing option should be turned on. Okay. Okay. Let's show rasters. If you open project cameras, we can see that all the cameras have been assigned to imagery of the project. Let's open one of these stereo pair. And let's add vectors toolbars and tools toolbar. Let's create new vector layer. And now I would like to show you how new stereovectorization tools works. So firstly, we can create new user coordinate system for aims of stereovectorization. For example, this direction will be direction of user coordinate system. In bottom left corner, new coordinate system appear. Then let me to create gable roof. When snapping option, when snapping mode is off, nothing happens. When I turn it on, I can see dash line that help me to select direction that correspond to user coordinate system. With help of snapping to coordinates, I can locate any object along with some line and make fast copy paste of this object. Well, as I said before, snapping to points is available, snapping to midpoints, snapping to lines, and so on. In detail, you can see a video tutorial about stereo digitizing in the PHOTOMOD YouTube channel. This video tutorial, stereovectorization new tools, is fully dedicated to new tools of stereovectorization. And finally, some important information for people who use the last update of Windows 10. You should be noted that just latest PHOTOMOD 6.3 version will work with Windows 10. It's caused by incompatibility of last update of Windows 10 with the protection systems of all the previous PHOTOMOD version. So if you have the last update of Windows 10, you need to update PHOTOMOD to 6.3. Well, that's it. It's all information I would like to present you. Please, in case of any questions, type them in question box. Okay, I see a question from Greece. Where can I find a manual for orthorectifying old aerial military aerial images? Well, actually, if you mean film imagery, in PHOTOMOD YouTube channel you can see video tutorial that's devoted to processing imagery captured by film camera. And of course, in addition to our YouTube video tutorials, you can find any information about processing film camera imagery in PHOTOMOD user guides. They're available in menu help or in official website of Rakurs company. Products, PHOTOMOD, documentation. One more question. I have a question regarding low block layout option in PHOTOMOD UAS. What does it actually do? Well, low block quality option, as I said before, is used when we deal with non-accurate external orientation data, when initial approximation of block layout is not enough to find type points. To use this low block quality option, you need to import projection centers and you need to split your block into strips. It's obligatory conditions. This situation very often occurs when rotation angles are not good enough. One more question. Is there a way to do automatic texturing of walls in case of 3D vectors, not mesh mode? Well, if we talk about vector 3D models, we have tools not fully automatic texturing by semi-automatic texturing of vector models. In 3D mode, after uploading vectors to 3D mode, there is an option of edit texture coordinates. So you need to upload vectors to 3D mode. All the walls will be automatically restored, and after uploading texture files to these vector objects, you need to locate these texture files across the vectors. So it is not fully automatic process, it's semi-automatic process. Using UAS, what are the optimal image overlaps for PHOTOMOD? It's a new question. Well, actually, the recommended overlap for PHOTOMOD using UAS usually is 80% per 80%, but of course usually depends on the output products you want to build, but recommended overlap percent 80 per 80. One more question. How to fill roofs with textures from True Ortho photo, let's say for complete city area? Should we split ortho mosaic to small pieces, 4000 pixel dimensions? Well, actually when I said about 3D tin, this procedure can be done in fully automatic mode, but as you understand, it will be not vector 3D model, it will be 3D tin as a continuous surface that can be splitted into separate objects. When I talk about texturing of vector 3D model in 3D mode, I mean something like that. Give me a minute to find a presentation. Well, what I mean, this video tutorial, if necessary, I will send you by mail. Just type your mail to give me chance to share it with you. Is about texturing of 3D models in 3D mode. So the main idea is if you have vector object in 3D mode, and if you have a file with textures that was preliminarily prepared. You can load corresponding vector texture that was preliminarily prepared, and to place every face of these vector models in corresponding with textures that we uploaded. So obligatory condition is the presence of this file with textures. So one object, one file with all the faces textured by photo. Can we do pre-processing in photo mode? So please clarify your question. What do you mean when you write about pre-processing? If we talk about converting rasters, usually before loading imagery into PHOTOMOD project, we recommend users to convert all the raw data, regardless its format, into internal PHOTOMOD format. Internal PHOTOMOD format is MSTIF, so regardless you have JPEG or BMP or something other formats of raw data, we recommend you to convert all of them into PHOTOMOD MSTIF format. It will significantly increase the speed of building pyramids in PHOTOMOD, and it will significantly increase the speed of processing all this data. So if I'm not answering all your questions, please clarify what you mean when writing about pre-processing. Okay, Andrish, I will send you this video tutorial, no problem. Well, please, any more questions, Mr. Kamalalandini? If you're still there, clarify your questions about pre-processing. Well, since we have not any more questions, Thank you very much for joining our webinar. It will be published in PHOTOMOD website in closest time. Thank you very much. Bye. See you.